Imagine if you could stretch, bend, and manipulate time. Sounds like fiction, right? Yet it's truth, per Einstein. Welcome to Time and Relativity. Think of time as a river flowing steadily, but imagine it speeding up, slowing, even swirling into a vortex. That's Einstein's relativity. Time is relative. Welcome to space-time, combining time and space into a four-dimensional fabric. This causes time to vary for observers, leading to some fascinating implications. Think about a pair of twins. One stays on Earth, the other ventures near light speed. When they reunite, the space traveler is younger. This is time dilation, a facet of time's relativity. But why does this happen? It's because speed influences time passage. Basically, the faster you move in space, the slower you traverse time. Not just theory, but fact. Experiments with high-speed particles and atomic clocks prove it. This isn't just theoretical. Scientists have confirmed this with experiments involving high-speed particles and atomic clocks. Time dilation morphs into something amazing and mysterious near dominant gravitational fields like black holes. Moving into the realm of relativity, where gravity isn't just a force that pulls matter together, but also manipulates time. The stronger the pull from these celestial bodies, the more sluggish the progression of time becomes. This interplay between gravity and time is not mere fiction, but is a concept well-founded in modern physics. This intriguing phenomenon is referred to as gravitational time dilation. To sum it all up, time is not rigid or constant. It's pliable, influenced by velocity and gravitational pull, leading to time dilation. This topic has engrossed both scientists and common folks. Intrigued by this dive into time and its relativity? Hit like and subscribe for more gripping explorations. I'd love to get your input. Any other scientific enigmas you'd like me to try to decipher? Comment below. Thanks for joining me on this adventure into the realms of time.